Well, I go, seems like a few weeks now without getting really any diags that are interesting at all. And today I get two. The RAM that you may have seen already, or you may see after this video. I don't know, because I just filmed part one of it this morning. So we'll see how this video turns out and see. And you might get to see this one or that one first. I don't know. We'll find out together, I guess. But anyways, this one is a 2011 Equinox that setting a throttle body code, and somebody's already replaced the throttle body and has a few other codes in it, and now it's kind of gotten a little interesting. I've started checking just a few things, just mainly looking at live data and stuff, and it's kind of interesting. So in my Prescan, you can see here I had a 5-volt reference 3 circuit code, which is history, but it also says current DTC, says power up, and then this throttle position 1 and 2 not plausible, and then the throttle body not learned because they just replaced it. So I've also got a wiring diagram over here pulled up on all data. And basically you've got on the throttle body here, you've got sensors 1 and sensors 2 for position. They're fed a 5-volt reference and then a low reference or a ground. So we've got this that we're going to look at. But what I found interesting was whenever I went into the engine, and I think I've already cleared the codes because I was wanting to see if that 5-volt one come right back or not. Let's see, display codes. We've got a new code in there. The APP sensors 1 and 2 not plausible. So let me show you that. If I go back out here and clear this, okay, go back in here, the throttle body code comes right back. All right, so, and when I crank this thing, it runs very bad. Immediate reduced power mode, like it runs very bad. But let me crank this, and I don't know if you'll be able to pick up how much this thing is shaking. But yeah, it's definitely running in reduced power. Sounds like only half of it's running. But anyways, what I was noticing, I was just messing with the throttle down here, and if I just push it all the way down, I get an APP code. Just pushing the throttle all the way down. So that's a little interesting. So I've got a throttle correlation and a pedal correlation. So let's go into some live data. And remember, we also had that 5-volt reference code for 5-volt 3. If I go all the way back out here, you can see it there, P0697. So if I go into my data, TAC data, for some reason Snap-on puts the 5-volt circuits in with the TAC throttle actuated control, if you didn't know that. But look at my 5-volt 3, it's slightly less than 5 volts. My others are all dead on 5 volts. It doesn't make a whole lot of sense for the throttle, because the throttle, as we see on the diagram, 5-volt 4. So both sensors on it run off 5-volt 4 and a single ground, and then you've got sensor 1 and sensor 2. On the APP, however, it uses 5 volt 3 and 5 volt 4. And that is for sensors 2 and sensor 1. And then they both have a ground. So there's two things I can go for. I can either go for the throttle body issue, or I can go for the pedal issue, because we've got issues with both. The throttle one, since somebody's already replaced that throttle body, I don't really want to start there, because we could very well just possibly be dealing with a bad aftermarket throttle body. So I'm going to start with this pedal. And what I want to do is I want to scope the 5 volt references. There's two of them, so there's 3 and 4. And then I want to scope the signal wires. I'm pretty positive my signal wires are going to read exactly what I'm showing here in live data. So if I go APP2 voltage and APP1 voltage, okay, I'm pretty sure when I scope it, I'm going to get those. And if I give this thing full throttle, my APP sensor says 84, but sensors 2 here is 99, and sensor 1 is 85, 86. As you can see, my voltages is at 2 and 3.5. If I let back off of that, you can tell they get within a half a volt of each other. So I want to know what my voltage coming into the sensor is, and if my voltage coming out is what I'm seeing in live data. If it is, then I want to then scope the grounds to see if the grounds have an elevation in them, like if they're not 0 volts. So let me get my leads hooked up down here, and we'll see what the scope shows. Okay, I've got my spaghetti hooked up. I just went straight down to the pedal. Get y'all in here and just back probed right in there to everything. Can't really see. It's tight area, but I got them in there. And on our live data, of course, we was showing APP2 is 0.47, APP1 is 0.94, and then our 5 volts is 496, and 5 volts there. So let's see what the scope says. And we have 5 volts, 5 volts. So that's a discrepancy right there. Or I'll go over what I've got in the channels. Channel 1 is the 5 volt 3. Channel 1 is 5 volt 3. Channel 2 is APP1. Channel 3 is 5 volt 4. And channel 4 is APP2. But let me see. Nope, scratch that. I told you backwards. Channel 2 is APP2, and channel 4 is APP1. So if we get back over to our voltages here, we can see our voltages for the APP sensors is exactly what scan data says, but my voltage on my 5 volts is slightly different than what my computer is seeing. So that's a little strange, but let's give it a crank and see what happens with our voltages. Okay, everything's still staying the same. Our 5 volts did drop just slightly, but nothing wrong with that. They're still at 5 volts. So if I full throttle this, we are showing 2 volts and 4 volts. What does our live data or our scan data say? Right now, APP2 is 2 volts APP1 is 3.5. So 3.5 here, but our scope says otherwise. It's in 4 volts right there. So scan data is showing half a volt off from what my live voltage is, but at idle it's fine. It's very interesting. But anyways, I've got our channel 1 and channel 3 swapped to the low reference grounds for APP2 and APP1. So channel 1 will be APP2 and channel 3 will be APP1. And this stupid key's messed up and it sometimes goes into theft. Stupid key. Okay, so let's see what we're showing now. Our grounds are basically 0 volts. Let's give it a throttle sweep. So nothing with our grounds so far. Grounds look good. And I am referenced off the battery. So far, I'm not real sure. Okay, so I've got all my scope leads moved out to the throttle body, and they're just basically channel 1 is in the 5 volt reference, which is 5V4. Channel 2 is in the ground reference. Channel 3 is in TP1, and channel 4 is in TP2. And I don't know that it's really going to help, because right now in our live data here, get this out of the glare. TP2 and TP1 are 5 degrees off from each other. Voltages is 1.6 and 3.3. If I go to my scope, that's exactly what my live voltage says down here. And you see channel 1 has got a good 5 volt. Channel 2 is 0 volts basically, so it's good ground. Channel 3 is 3.3 volts, almost 3.4, and channel 4 is 1.6 volts. So back on our live data, this is exactly what our live voltage says. Now when I crank this thing and give it some throttle, you'd expect these values to change because you can hear the engine rev. But they don't move at all. This throttle body is not moving. What it's actually doing is when I hit the APP, hit the accelerator pedal, it's actually letting the engine run up to that RPM. We're actually stuck at this 26 or 21 degrees, one of the two. It actually says that on our live data, do they agree? No. Indicated angle is 26, okay, but our desired angle is 2 and 4. It's wanting to close the throttle body, but right now it is not closing the throttle body. So what I want to know is it just defaulted at this 20 something degrees, you know, basically no throttle movement at all because of the code. Well, if we go out here and clear the code, it's going to retest the throttle, and for a split second we ought to see some changing in our voltage on the scope. So let me make sure my scope is running. Yep, we are recording So let's go clear these codes and see what happens. As soon as I hit this, the engine tone is going to change and it's going to move the throttle a little bit. Okay. Let's stop that. And let's see if we see that in this voltage. Yes, we did. Right over here. So as you can see, this basically is a mirror image of each other. Okay. That's when the throttle moved. The blade moved. The sensors go inverse of each other. So what's the computer fussing about? Is it that 5 degrees they're off? I think I need to do a little bit of reading to see what my spec is on this. Okay, so we go over to the all data and just look up this DTC. It's a P2135. Several ways you can find codes, and some codes are mixed in with other codes, so when you search them, you can't really find them. But if you just go through the list, 2135 takes you to it. So here it is, 2135, throttle position sensors 1 and 2, not plausible. So basically, they don't correlate. And for sensor typical data, hey, we got typical data. Short to ground, open, short to voltage. So yeah, their typical data isn't very typical. I mean, it's not really telling us a whole lot. Well, I guess normal range is 3 volts to 4 volts for sensor 1. We was at 3.3. And sensor 2 is 1.4 to 2.4. So they both work in a 1 volt range. So they're looking for 1 volt range moving apart from each other or coming together, one of the two. And it is 1.4 to 2.4 and 3 to 4. So that's good. And this is operating condition. Engine is idling, so it should see a voltage somewhere in that. We're there. We're in that. So let's get down here to what sets the code. ECM detects that sensors 1 and 2 disagree greater than 7 to 10% for less than 1 second. We're only seeing 5% difference. And that code is setting right away. Like instantly that thing sets. So ECM commands the throttle actuator system to operate in reduced power mode. Basically it is whatever the spring holds the flap at. We ain't getting anything else. I'm just kind of reading over the flow chart to this thing, and pretty much some of these we can rule out. Okay, so doing the circuit system testing basically wants us to disconnect the harness at the throttle body, and we're going to check for the low reference to make sure it is less than 5 ohms. Well, we know from the scope we read 0 volts, so we don't have an issue with path to ground. If we did, we'd see that voltage elevated. Okay, our 5 volts with the ignition on, well, we know with the scope we've got good 5 volts loaded. Okay, and then it wants us to measure TP1 and TP2. TP1 should see less than 1 volt, and TP2 should basically see 5 volts. So basically TP1 is being pulled up from ground, and TP2 is being pulled down from 5 volts. So really what I could do is basically just turn the key on and unplug it and see what our voltages is on TP1 and 2 and see if they match that. And if they are less than 1 volt and the 5 volts, guess what? It's replace the ECM. So could we be dealing with a faulty ECM? Well, maybe. So let me do this. Okay, so we're just going to turn the key on. We see our voltages come up. Okay, so 5 volts, ground, and then TP1 and TP2. So whenever I unplug, we should see channel 4, TP1, goes to 5 volts, and TP1, which is channel 3, should go to 0 volts. So let's see what happens. And I'm hopefully get this out. Come on. Alright. Come on. Okay. Unplugged. Let's see what happened to our voltages. TP. Oh, look. 4. Well, go back down. So 4.5. That should be 4.8. That's interesting. So TP1 should be ground, which is 3. It is 150 millivolts. 130 millivolts. So that's good. It's less than the 1 volt. It says less than 1 volt. So that's good. And TP2 should be 4.8. We're at 4.5. So we're actually a little low on that. I would expect that basically be spot on 5 volts, really, since it's on the 5 volt and it's expecting to be pulled down. Now, if it says right here, if less than specified range, test the signal for a short to ground or an open high resistance. If the circuit tests normal, replace the ECM. So now it's wanting us to specifically test that one circuit from basically the ECM to the throttle body, making sure that it has no resistance in it, and if it has no resistance in it, we got a bad engine computer. So what's the best way of testing this? I think probably just a loaded test light bulb. Unplug it at the ECM, unplug it at the throttle body, and pass some current through it. See what our voltage loss is. So let's do that. So real quick here, in the diagram from GM, it actually does show this being a pull down. This would be a pull down because we got basically our 5 volt here fed through a resistor, so it's looking for this to be pulled to ground. And this one would be a pull up. We've got ground through a resistor, and it's looking for this signal to be pulled up. So the diagram actually tells us that which ones they pull up, pull down, and that's kind of how you identify them. Okay, so I've got a terminal here in the purple wire, which is our APP2, and I always use probably just a slightly smaller terminal than what's needed, just to help keep from spreading terminals. So It's just barely sitting in there. Sitting there good enough to make a connection. And the other end of our meter is on ground. And you can see we're at 221 kiloohms. So either that is just normal, like circuitry through the module, or that has some extremely high resistance to another wire that it's shorted to. So let's just unsnap this and see what happens here. Oh well. Okay, so that means that it should be in this, or another wire that is connected in there that goes to ground. Very confusing, but terminals all look clean. So now I just want to basically pass some current through this thing and see if it's got good connection there. Alright, so I found my terminal here, and as you can see, we're at 2 ohms, which you would think is a good circuit. Possibly is. I'm still curious about that 220 ohms. So what I want to do is actually find this terminal on the ECM. So we're 3 over and 3 over. Okay. And I want to know if the 220 ohms is from the module. So just regrounding my meter and connecting in here, if I could get my hands to work. Alright, 220 ohms. Okay, so that's fine. Or 220 kilo ohms, sorry. That's got a K in there. So that is in the module. So I don't have to really worry about that wire being somehow shorted to another wire. So I know we're good. So now let's pass some current through this thing and see what kind of voltage drop we got. Okay, so what I've got here is the jump post basically run through just this little lead going into the ECM connector. And as you can see with my meter, I got 12.3 volts. Okay, and the other end is run through the wire, through the bulb, into ground. As you can see, the bulb's bright, meaning I've got at least 2 amps. This is a 2 amp bulb. So I've got at least 2 amps going through this thing. And coming into the circuit, we've got 12.3. So coming out, if we had a voltage drop in this wire due to resistance, we should be able to measure right here and see a voltage drop. So 12.29, we plug in right here. .1, so 290 milliamps. Double check this back over here because my battery voltage is going down some. So 29 and 11. So 180 milliamps. Is that enough to worry about? I don't think so, because we're carrying 2 amps of current. Plus, I've got connection. This connection right here is not even tight. So this is just kind of setting in there. So another connection. So with all the connections, less than 200 milliamps of drop on that's loaded to 2 amps on a circuit that doesn't carry but milliamps. I don't think that's enough to worry about. So it's kind of looking like a bad ECM. Kind of looking like it. It's such a difficult call. Your data looks good, your voltages look good, your test all look good except for the one test where my voltages is slightly off. Before we condemn the module, I guess we could check powers to it. We know the ground is good because I would have a bad ground getting to my TC or my throttle body also. So, and I really don't think it's a power issue either. Let's go through and test all of our powers and grounds anyway. Sorry, it's getting a little bit windy. Had to get my dead cat. Hopefully the audio still turns out okay. But anyways, let's check these powers and grounds. And on the all data here, we've got ignition and battery, and then a ignition trigger, like an ignition relay trigger, ignition from the relay. So let's check the battery here first, and then we'll check this ignition, and then we'll check these right here. And then lastly, we'll check those grounds. So, got just my meter with 2.5 amp test light bulb connected to battery ground and terminal. And I know from my diagrams or my connector views that this one is X1. They give you description of each one of them. So this is what it is blown up. You can see 73 is here, 52 is here. So we're going to be looking at 52 and 51. But on the connector view, it says black with blue terminal position assurance lock. So that's this guy. Okay. So, like I say, we're going to be looking at 51 and 52 and 73, 72, and 73 on the other two grounds. So, on our 52 here, let's see. Yeah, 52 right there. Okay. Got bulb 11.8, and my ground's not doing too great, but anyways, 11.9. That's not bad. I know my battery's getting a little weak. And then right here is the ignition, so 51 right here. So let's turn that on. Got a bulb, 11.8. Dang it, I didn't mean to hit that. Go away. So 11.8. So now I need to check this one right here, because this one is going through this relay right here. So I need to turn this relay on. What I've got is another bulb that is connected into ground, and if I just take it and get it into pin 72, we get bright bulb 11.8 on our 73 terminal. So now we just need to check these two grounds. And all I'm going to do for that is move this from my ground to this little jump post here, and basically do the same thing. 11.9, bright bulb, and my next one is 11.9 and a bright bulb. Now I could go through and redo all this with a higher amperage bulb. This powers and grounds is not my issue with this one. It's just not. If it was a ground, I'd see it in my scope captures, because my low reference would have to use that engine ground, and I was always referenced to battery ground, so my ground would have been elevated. So I'm calling a bad ECM on this. Sadly, this is going to be a Global A module. It's a E39, I believe. If you get this thing out. Yep, E39. And currently, I don't have a way of cloning that one into a used module. So they might be left getting a new one for now, or who knows. Maybe I might buy the stuff finally to do. I need to get the stuff to clone these things. But anyways, that's what I'm calling a bad ECM on this one. This one's a hard one to call. It doesn't really explain the APP code unless I went through the diag chart and my APP voltages are not the same like it's supposed to be. And we also seen that 5 volt says it's lower than it actually is. It's actually putting out 5 volts, but the data shows 4.8 or 4.9. So that was a little strange. Could just be a bad ECM all the way around. Kind of tempted to unplug the APP and kind of go through that flow chart to see what my voltages are coming out of the ECM for that. But I feel like I'm going to run into the same thing. And either way, it doesn't change my diag for the throttle body. So, calling a bad ECM, I'll get with the customer, see what they want to do as far as getting a module for this thing. If I have to, if they want to get a used one, because maybe that's the only thing we can get, I don't know. I haven't tried to get an E39 lately. But if we can't get a brand new one, maybe I can get a used one. I'll send it off to somebody and have them clone it for me or something. But anyways, that's it for this one today. And hopefully you guys enjoyed it. If I can get this stuff to do the ECM and clone it or whatever, I'll do a video on that. Promise. If not, I'll just be doing a brand new module or sending it off to somebody, having them clone it, and then sticking it in. But that's it. I hope you enjoyed it. Hit that like button, hit the subscribe button, and as always, if you found it helpful or anything like that, share it with your friends, your colleagues, anybody in the industry that might be wanting to get more involved with diagnostic tests, scope usage. Use the Veris Edge a lot when I'm on mobile calls like this, because it does most of what I need for mobile calls. If it won't do it, then I'm going to have that brought to the shop to use the Pico with probably. But anyways, that's it, and we'll see you later.